Ja, men jag kör som ligger 40. Smör, olika smör. 2 fötter ut. Fatna. Och fatna. Rent ut. Och innan släger lite på. Som har gått. Och 2 fötter bänt. Fatna och ut. Fatna. Okej, Christian, sötna.
God daginn og velkomin hingað á þennan fund til Brunateknikfélag Íslands. Við erum hérna með gest frá Noregi, Erik Mengsvold.
Yes, Erling Mengsvold.
Já, Mengsvold. Og hann ætlar að kynna fyrir okkur nýjungar á svið mistutkerfa, tókutkerfi og það sem að gerast í hérna Noregi og þetta er bóði Sigur og félagar frá misturkerfum sem á heiðurinn af því að þetta með heimsókn. Þannig að ég gef henni bara orðið laust. Varsågod.
Thank you very much. Thanks for having me. Nice to be back in Iceland. It's my second trip here, without just stopping through Keflavík. So that's good. So we're here to talk a little about the pipe system. I think has been announced. I didn't understand what your intro was exactly, but there's probably a very different level of knowledge in terms of water mist. So I think if I could just have a show of hands, just so I know, how many are fire consultants in the room? Okay. And how many are designers? Okay. Fire department? Yeah. Okay. Yeah. Good. And installers? Any installers? No? Okay. So we'll spend less time on that. I'll definitely get to the pipe system that we have, but I thought we'd also go through just a little bit about water mist. A lot of things have happened, especially over the last couple of years, and last year alone, in terms of standards. So I think before I show you all the solutions, it's important that you know that you can actually use the solutions according to existing rules and regulations with the standards. So that's what I was thinking of going through. Just a quick introduction. I was with my partner founding P3160812 back in over 10 years ago, 2007. We are the leading supplier of water mist in Norway. We have a pretty big market share, as you can see, of the overall water mist market. Way back when we started, 2007, we were focused in on the residential market because we knew back then that the laws, the regulations in Norway would require suppression systems in residential occupancies. So that was a market that we really focused in on. And as you can see, we have a big share of the residential water mist market. Now water mist as a total compared to sprinkler is a fairly small market, right? So for water mist in residential in Norway, we actually have almost 10% market share for the overall market. So it's starting to build up. And really it's last year that we're starting to promote this. We spent a lot of time testing, researching, and also certifying our equipment. That takes a lot of time and money. But now we are the first company to successfully have passed the test requirements for the Nordic standard for water mist and residential. Did you guys know that there is an inter-Nordic standard for water mist? Yeah? Insta, okay. So you use that now, and I'll get a little bit more into that later. The ACE 900 Part 3, which is the water mist tests, are based on the British tests. So way back when we sat down, I suggested using these tests from the British standards, 8458, to get the standard in place for the Nordics. So that was a good thing. So we were the first to have tested already these back then. And we're also tested to a commercial low hazard, which is mostly ordinary hazard occupations. Would be, office building, hospitals, anything ordinary hazard. And we are the first ones to have certified automatic nozzles, water mist nozzles at LPCB. So when you're first through the system, it takes time, unfortunately. And the last thing now is that we have the technical approval by SINTEF, because there is not a harmonized standard for pipe and pipe. So you have a technical approval by SINTEF, which I think most of you know, certification institute in Norway. There is a video, and I think I'll have to just play it off the website that introduces. So on our website, you can click on. Go back. There. Just click on news on the video, and this will come up. It could be a good one to refer to. There's the volume.
Good.
Cool. You can't hear that, can you?
Hardly. Nobody who works here. The master volume.
Is there a way to adjust it?
I don't know. Just a minute. Is it fully or?
Yes, fully.
It's full. I don't see. Anyway, I can call a.
How about the master volume?
Ah,
If you press escape, you can see the volume in there.
ja.
Maybe you can stop video.
Ja, henne. Ja. Of course.
Releases the oxygen and suffocates the fire. The droplets that are not converted to water vapor will wet the surrounding area and prevent the fire from spreading. Each year, thousands of people die in building fires. In addition to lives lost, fires cost owners and society billions in damages. As a result, authorities around the world are implementing stricter regulations, requiring the installation of automatic fire suppression systems, especially in buildings that house the most at risk, the elderly and disabled. A solution that is becoming more prevalent and in demand is water mist, mainly because it requires significantly less water than traditional fire suppression systems and is proven to be very effective in controlling and extinguishing fires. Prevent Systems researches, develops and distributes patented low-pressure technology and is a leading supplier of water mist suppression systems. But what is water mist and how does it work? Water mist is defined as water droplets less than 1 millimeter in diameter. Water from the mains or a tank flows through distribution pipework and is atomized to many very fine droplets as it passes through a water mist nozzle. Many tiny water droplets create a greater total surface area per liter of water. The smaller droplets absorb the heat from the fire and lowers the temperature quickly. The fine droplets in and around the fire boils over from water to steam, or water vapor, which is an inert gas. This conversion to water vapor dramatically increases the volume of water by almost 1,700 times. The water vapor displaces the oxygen and suffocates the fire. The droplets that are not converted to water vapor will wet the surrounding area and prevent the fire from spreading. Effectively, the fire is attacked from all sides of the fire triangle: heat, fuel, and oxygen. Exploiting water more efficiently has its obvious benefits if a fire should start. In addition, less water requires a smaller water intake and smaller pipes, resulting in easier, faster, and space-saving installations. This, of course, is very important to builders, architects, contractors, and owners. As an example, let's look at an installation for a typical apartment building. A pump setup is placed in the building's technical room by the water intake. Corrosion-free distribution pipework is installed. Rigid pipes are used for open spaces and to supply water to the apartments. with floor dividers in concrete poured on site or floor divider elements hoisted into place, the housing box connector for the water mist nozzle is embedded in the concrete. The installer can then easily connect the leakage-proof, flexible pipe-in-pipe system before the concrete floor is poured on top. Safe and complete fire protection, quick and effective, corrosion-free, leakage-proof, with replacement pipework. Prevent Systems water mist systems are fire-tested in full-scale fires at accredited fire laboratories according to international standards, with full documentation for applications to be protected, as regulations require. Prevent Systems was the first company to meet the test requirements for the Nordic Residential Water Mist Standard, Insta 900-3, and the British standards for residential and domestic, BS 8458, and for low-hazard occupancies, BS 8489. We were also the first company to obtain certificates for water mist nozzles from Loss Prevention Certification Board, one of the world's most recognized certification institutions. With hundreds of installations, our systems have proven to be very cost competitive. With a corrosion-free quality, maintenance costs are reduced, which yields a total economy that make them even more attractive to own. We supply automatic low-pressure water mist systems to hotels, apartment buildings, schools, daycare facilities, office and commercial buildings, care homes, hospitals, institutions, and heritage buildings. Our reference list is growing fast and even contains the world's largest inhabited castle, Windsor Castle in England. To find out more, contact us at www.preventsystems.no.
Okay. So actually you saw that Windsor Castle in England? That was the first installation with pipe-in-pipe in the UK. They don't use much pipe-in-pipe there at all for sanitary either. So we had a training team come over from the manufacturer in Switzerland and train them on how to use the pipe-in-pipe system. So there's actually quite extensive use of pipe-in-pipe in Windsor Castle. Just as a note. Okay, so now the video explained water mists. I'm not really going to talk much more about that other than to say that, you know, for temperature, oxygen, and then attacking the fire load, you are sort of attacking the fire from all three sides of the triangle. So the question then is, does it work? And of course I'm out there saying it works. I have a vested interest in saying that it works. So it was nice last year when SP in Sweden, I don't know if you know SP, or it's now RISE in Sweden, Research Institute of Sweden. The state of Sweden, they wanted to actually do a comparison test of residential sprinklers. So they wanted to see residential sprinklers using 47-degree bulb, 57, and 68 degree to see if there's a difference in reaction time. And they wanted to compare that to water mist. And they used 5 different water mist manufacturers. And we were one of them that submitted nozzles. So we were not there at the tests. They ran the tests, the setup and everything. But the results were quite interesting to find out. And the Swedish Brandposten, I don't know if you get that, Brandposten, released an article on it. This is a larger presentation that will be made this summer at the International Sprinkler Conference, which will be held in Stockholm, Sweden, this summer. But what they found is that when you compare residential sprinklers to water mist, this here shows you a residential sprinkler head right before it operates. So this is the fire load here. This is 2 minutes into the fire after the sprinkler has operated. That's what the fire looks like. And this is after the fire is over. And for illustration purposes, they used actually our nozzle, low pressure water mist nozzle. This is right before the water mist nozzle operates. This is 2 minutes after, so compare there to there, and that's the result after the fact. They used different fires to compare things with, and they used also, like I said, different temperatures. For the temperatures, when they showed the different temperatures here, it wasn't really that much of a difference, surprisingly enough. And I think that has a lot to do with once the fire gets going, at one point it increases so fast, so the bulb doesn't operate, whether it's 47, 57, 60, you know, it happens so quickly. So you have almost the same type of reaction time with these type of fires, because the fire room was only 13.4 square meters. Small, small room. Now, here's our result. Here's the residential sprinkler. This is for residential sprinkler type 1 and 2. 1 and 2 means you have 2.04 millimeter per square meter per minute. That's the design that you do. Now keep in mind, this is only in a 13.4 square meter room. How big a room can you use these nozzles for? Up to 37 square meters. So what would the result be if the bulb wasn't that close? Right? The result could be a lot worse. Now, one of the benefits obviously of a sprinkler is that when you design a sprinkler system, you do get more water coming out of the first nozzle operating. So that's an advantage, right? So you get more water than what they run with here, the minimal. Actually, that's the same with low pressure water mist though. We also would get more water, more pressure on the first nozzle when you design it. So it's sort of an apples to apples comparison. But when they double up, so here you have the results when you also compare the 4.1 millimeter nozzle. So that's for Insta 900 Type 3, so for care homes and things like that. And still, you would see that the result is significantly better than using double water, using water quantity here. So kind of a surprising result to the tests for many, I think. And this will be going on through the presentation then in the sprinkler conference this summer. They looked at the temperatures, obviously very important. So here you have residential sprinklers. Here you have water mist. There's 5 companies. When you look at the free burn, obviously the same. Burns the same. Here is then the type 1 and 2 sprinkler nozzles up to over 400 degrees. And over here you have about 150. With the double water density, 4.1 millimeter, you're down here compared to then the water mist down here. When you look at the eye height temperatures, you see you're over 150 degrees here. That's pretty uncomfortable. Whereas all of the water mist are below 50. So it has to do with, again, attacking the fire from all 3 sides of the fire triangle. When they, in the results of the test, they do make the conclusion here that with especially with our nozzle and also the high pressure water mist nozzle at 80 bar, you have similar results here to the double density residential sprinkler, but using 1/4 to 1/2 of the water. So much more effective in terms of usage of the water, exploiting the water. Just important to sort of put this in perspective because, of course, I'm out there talking about it all the time. But it's nice to have some backup, third party. I hope that illustrates that it does work. I mean, water mist has been around for a long time now, and here to stay, I think. But it's important to fill in before you go to the solutions in terms of how does it work with the current regulations and the standards. Because a lot of people I hear, saying, okay, yeah, it's water mist is fine, but we don't have a standard to use for it. We're missing some rules and guidelines, what have you. And that's a little bit of a myth, and has been since we started with this. The reason I say that is, if you look at sprinkler, you're familiar with the EN 12845. That's the commercial standard for how you would design, install, and maintain a sprinkler system. Of course, have the Insta 900, part 1, for residential. Part 2 is how you test a residential sprinkler nozzle, which most of you probably wouldn't know the document, but you would use part 1. Now, for residential, since the European document here does not contain residential, That's a Nordic standard for residential. They are working now on the 16925. So there will be a European standard for residential for sprinklers. It will be very similar to the Insta. The big discussion points among the countries is how much water should we require, the water density, how large an area should one nozzle be able to cover, that's another area, and then what's the length of time, the duration the system should be designed for. So those are big topics that still remains to be solved for the residential sprinkler standard. Have anybody read it or heard about it? No? For water mist, you have obviously the Insta. We talked about the Insta. And of course, once you have passed these tests, you're referred then to how to design, install, and maintain here. Okay? The difference will be how much water did you use in your test, what type of pressure did you use, and how long is it between the nozzles, the spacing. We use the Insta 900 Part 1 to design and install the system and maintain the system. Then you have, like I said, the two British standards. And the British standards are important because they were the first national standards to be published. There are other water mist standards, but these are British standards. So UK stands behind these. So we were the first company, like I said, to do both of these fully. But in addition to that, we were able to incorporate these two standards into the European document. So the European standard for water mist will now be coming. The European standard was on public hearing last summer, started in June. So when it's public, it means you can purchase it, you can refer to it, okay? But it's not a final standard. So you would have to say that changes could happen here, but this is the document that I would refer to in use, right? In the hearing, we received 346 comments. So we took two-day meetings, went through all the comments in the technical group. So now all these comments have been completed, and the document will be put back on hearing this summer. So we have a new meeting now in November to go through, hopefully a lot fewer comments. And then we expect then final publication of the standard to be early, or first half of 2019. That's the time frame there now. But like I said, it can be referred to now. So to say that water mist doesn't have a standard is wrong. And you know, you can also use existing sprinkler standards as long as you can prove you can do it as good or better. Okay? So, so that is available. Now, the document that is out on hearing is the main document that looks like the 12845. So 14972 is essentially the 12845 for water mist. But it does include, in addition to Part 1, Part 1 is the design installation that you would refer to, but then it has 16 fire test protocols referenced in the main project. So if you wanted to protect the parking car garage, it says right here, Part 5, test protocol for car garages, automatic nozzles. And that is based on a VDS standard. The two British standards is Part 7 here, which is commercial, low hazard occupancies, that's an LPCV. And then you have Part 17, which is residential. And that is also the LPCV or the British standards that this is based on. So again, you have now, based upon the occupation that you are consulting on, or if you're designing to, you have now the test protocols that would be appropriate for the application. Some of these standards would overlap. So some, you would have a hotel ordinary hazard can be also used with a VDS standard. So you're not tied into just one. You have an election. But that's important to know that all these now are available publicly and can be referred to. Another note too, when you know the 12845, it's nice to know that the 14972 uses the same classification of buildings. So you have ordinary hazard 1 would be 72 square meters. Number 2 would be 144. So it's the same So that would be easier transition. Performance-based versus water density-based. Obviously water mist, like I say, you have to successfully pass these fire test standards we just referenced. The design and installation is based on those test results, so that'll tell you the flow rate, the pressure, the spacing, the ceiling heights that you've tested to. That's very different than sprinkler. Sprinkler has been there around for hundreds of years, or not hundreds, but 140 years anyway, right? You have international standards, they're based on spreading water in a given area with a given water density, okay? The challenge with that is, if you say you're going to secure this building here now, this will be an OH1 application, right? So you have 72 square meters, and you have to have a nozzle providing how much per nozzle in water?
12. No, 17.
No, so 5 millimeter
No.
per minute per square meter, right? That's the standard, okay? How are you going to improve on that? It's tough, right? Because it says you have to use that, 5 millimeter, that's the standard. So then you have to prove that you can do it as good as 5 millimeter or better. And that's what all those other test protocols are for and based on. So in other words, if you were to secure this university here, kindergarten, office building, hospital, shopping area, concealed space, theater, parking car garage, answer, it's easy, right? But we know this is not the optimal solution. There are ways to do this better with less, you know, if you can optimize for the application you're doing. So I think at some point in time, you know, this will sort of ingrain, because when I started with this, I think, you know, I was thinking logic will win. If I can do this as good or better with less, why not, right? We can go from A to B now without using diesel. So it's possible. But anyway, so that's not a performance-based solution. But what performance-based means is that you basically have a test standard, and all the basis for these water mist tests are sprinklers. It started back in, this is from Magnus Arvidsson, did this study back in, publication was in 1995. But back in 95, water mist was very sought after for maritime, for boats, shipping, right? They have to have suppression systems on these cruise liners and ferries. And what they did is they ran 44 sprinkler tests, and they measured the temperature and the loss of the fire load. If you can then keep the temperature at this level, keep the fire losing this much, then you have done the job as good as sprinkler at 5 millimeter. Okay? So 44 fire tests were done. Based on that criteria, the criteria for water mist came about. So when we first tested back in 2009 at SINTEF, these are the type of tests that are basically part of every test protocol for land-based applications within ordinary hazard and residential. These are the most repeatable tests, most robust tests to test it, and they're not easy. But what you have here is a ceiling within a fire hall. This is minimum 80 square meters. And then you have 4 nozzles coming out, and you have a fire load. If you notice here, this is from 2009. See the pipe in pipe? So this is a simple pump set here. Here's the water intake from the fire lab, our pump, up to distributor, and then we use pipe in, pipe out. They were wondering, how are you going to protect your pipe here from the fire load? There's a lot of